All right. Let's go here. Let me check one other thing. I will get everyone else. I'll check attendance again around the 15-minute mark. So, that's how we'll work that. Okay. All right, scholars. So welcome. Hopefully you enjoyed your weekend. Only real announcement is you can anticipate exam 3 to become available this upcoming Sunday. I haven't really checked to see what time I schedule it for, but usually I schedule them to become available on the Sundays at 11:11, and then the exams are due the following Sunday at 11:59 p.m. Sunday night going into Monday morning. This exam will cover chapter 2. So today we're going to be concluding chapter 2 with section 2.3, dividing polynomials and the rational zero test, right? So, everything is going to be over in the blink of an eye, right? So we're going to work on this section this week. Next week, we're going to devote the entire week to just the exam. So, the examiners will be available, and I'll probably just be on the call and just be available for questions. I'll probably sit in silence until you guys request something. But you can ask me questions about anything that's on Pearson, a current exam, old exams, anything that's on Pearson next week or anytime, really. You can ask me questions about it. We can talk about it. We can work on it together. It's not a big deal. But so for today, we're going to go ahead and take some time and explore 2.3, dividing polynomials and the rational zero test. As always, this is remote asynchronous, so you know the spiel there. If you have questions, feel free to unmute yourself to get my attention, or you can type in the chat. I do check the chat periodically, okay? So with dividing polynomials and the rational zero test, we have a few objectives. 1, we like to learn the division algorithm. 2, we like to use the remainder and factor theorems. And then 3, we like to use the rational zero test. So with my students earlier, we made it through objectives 1 and 2, and we kind of briefly touched on objective 3. So whatever we don't finish together, this should be in my recorded lecture that's available already on my channel in the playlist. So then we have this, what do we mean by a polynomial factor? So we say a polynomial d of x is the factor of another polynomial f of x if there's a polynomial q of x such that f is d times q, right? Well, where this is your divisor, this is your quotient, and this is your dividend, okay? Divisor, quotient, dividend, okay? Right. So if a polynomial f of x is divided by a polynomial d of x, where the dividend is not 0, there's a unique polynomials q of x and r of x. So long story short, so if you say f divided by d, or your dividend divided by your divisor, the output's going to be your quotient plus your remainder over your divisor, right? If you use algebra and solve for f here, multiply both sides by your divisor, then you get the dividend. It's going to be the divisor times the quotient plus the remainder, right? That's a whole bunch of jargon, but long story short, a simple way to kind of visualize this. So this division algorithm is going to parallel like long division with numbers, right? Let me see. Hopefully it'll let me add a page. It's kind of been throwing a tantrum all day every time I try to add a page, and it looks like it's throwing one now. Maybe I have to update my software or something. I don't know why it does that. I hadn't figured that part out yet. So I'm trying to avoid having to reboot my system. Let me go back. Let me close this out one more time. And I'll check attendance for the latecomers in like another 10 minutes. Okay, let's try this again. So right here, I want to add a page. Okay. And then templates. And I want it to be like this and apply. Okay. All right. Okay. So, just a quick demo for instance. Let me see, the time is like, let's do 2:06, right? So say we were considering 2:06. Let's add a 1 on that, all right? And we divided that by, let's divide it by 9, right? Here, let's do this. I want to change the 9 to a 6 and change this to a 4. Okay. So, the same way we would do the procedure here, when we do this division algorithm, it's going to follow a similar pattern, right? So first we might say, how many 6s are in 20? Or what's 20 divided by 6 is what, 3? Right? 6 times 3 is 18, right? So on this diagonal, we multiply, and then here we subtract, right? So then we get the 2, and then the 6 comes down, right? What is that, 4? 24, remainder of 2. This guy comes down, right? Then that's 4 even. All right. And our remainder in this case ends up being 0. No remainder, right? So this procedure, how we did this here, when we do the division algorithm for polynomials, is done in a similar fashion. Okay. So here we're asked to, I'm going to have to add another page. Use long division and synthetic division to find the quotient and remainder when this is divided by that. Okay, I need a page. Hopefully it lets me do it without going tantrum. Yay. Okay. Okay. I need to get a copy of this. I guess I can just screenshot it. And actually, I really just want this. Okay, this is what we're working with. So we're going to see this in 2 ways. We're going to see polynomial long division, and then we're going to see synthetic division. As soon as I can get this to behave properly. There we go. That's better. Okay. So let's do a demo on polynomial long division. So our divisor is going to be this x plus 2. Okay. We're dividing this into this other polynomial. Now, when we list out this dividend, we had to make sure that every power is accounted for, right? So if we started with the power 4, power 3 is accounted for, power 2. We're missing power 1, so we need a placeholder, and then the constant is power 0. All right. So we got 2x to the 4 plus x cubed minus 16x squared. Now this is where we need the placeholder. So we're going to say plus 0x and then plus 18. Okay. Okay. So then in a similar fashion, we're going to say the first term divided by the first term. So 2x to the 4 divided by x is going to be 2x cubed. And I'm just going to line up my like terms right here, 2x cubed. So next on the diagonal, we multiply. Okay. So then 2x cubed times x gives us 2x to the 4. 2x cubed times 2 gives us 4x cubed. Okay. And then the next thing we did, we subtracted. So we subtract on this line. We had to distribute a negative. Okay. So it turned the first term positive and it turned the first term negative and the second term negative. Okay. So now when we combine like terms, a number plus its opposite, these add to 0. 1 minus 4 is negative 3x cubed. Then the negative 16x squared just comes down. Okay. And then we repeat the process. The first term divided by the first term. So negative 3x cubed divided by x is going to be negative 3x squared. Notice I'm lining up my like terms. On a diagonal, we multiply. So then we're going to get negative 3x cubed minus 6x squared. And now we have to distribute a negative. So this becomes positive, this becomes positive. Okay. A number plus its opposite, these guys add to 0. Negative 16 plus 6 is going to be negative 10x squared. The 0, this comes down. Right, so hopefully you can see how this parallels what we did a minute ago with a regular long division. So now we just repeat the process, the first divided by the first. So negative 10x squared divided by x gives us negative 10x. Okay. On our diagonal, we multiply, so we get negative 10x squared minus, it looks like it's a 20x. Distribute the negative, so then this is going to become positive. This becomes positive. A number plus its opposite adds to 0. We get what? 20x. The 18 comes down. Okay. First divided by first is just going to be plus 20. We multiply back, we get 20x and 40. We distribute our negative. This adds to 0. And I think that's a negative 22. This is our remainder. Okay. I feel like there should be questions, but you don't have to ask questions. If you're not going to ask me directly, as long as you're at least working with, a classmate that's getting it, or one of the tutors that you pay for, just a tutor, because you've paid for the Morehouse tutors that's included in your tuition, but you might have your own tutor. That's fine. Just as long as you're getting support or you're figuring out a way to get it done. Okay. 2x cubed. Now, that was a demo on polynomial long division. Let's do the same thing. Can I just copy? But now let's do a demo on synthetic division. Okay. So then with synthetic division, come on. I know you can. There you go. Okay, so when we go to do synthetic division, the first thing is we want to identify the 0 of our divisor, right? So here's our divisor. The 0 here is going to be negative 2. So we're going to put negative 2 in the chair. Then the same way we had those placeholders, we want to write the coefficients from our dividend. But we got to make sure that every power is accounted for. So power of 4 is 2, 1, negative 16. Now, since power of 1 is missing, we need a placeholder. And then 18, right? So because we started with the power of 4, we should have 5 numbers. 1, 2, 3, 4, 5, okay? So that's the setup for synthetic division. Now, we can only do synthetic division when the divisor is a linear binomial. When it takes on this form or this shape, okay? Let's see. So then the first thing is, the first number just comes down, right? So the 2 just drops down. And then on the diagonal, we multiply. So negative 2 times 2 is negative 4. Vertically, we add. Diagonal, we multiply. Vertically, we add, that's a negative. And then diagonal, I'm saying -2 times -10 is a +20. Vertically, we add. And then diagonal, we multiply. That's going to be what? -40. Vertically, we add. And that's our remainder here. This is our remainder. So because we started with the degree 4 polynomial, this is what's called the depressed equation. So we go from a degree 4, and now we're going to be at a degree 3. So that means that this part here is going to be 2x cubed minus 3x squared minus 10x plus 20. Okay. So we have our remainder of 22 and our depressed equation. Okay. I think we got the same thing in either case. You can see a typed version of it here. And then you can see synthetic division here. Okay, let me just take a moment to check on you guys in Zoom. All right. Okay. And let me share my screen. All right, let's get back to it. So we saw a demo on polynomial long division, which was similar to regular long division with numbers. And then we saw an extension of it with synthetic division. Although, give me just a moment. Although synthetic division was faster and easier, in my opinion, we don't always have the luxury of using it. Remember, we can only use synthetic division when the divisor is a linear binomial. So it takes on the form of like x plus some number or whatever. It has to be in the form of a linear binomial. So if a polynomial f of x is divided by x minus a, then the remainder is given by this guy. Okay. So the remainder, there's a correlation between the remainder and evaluating your function at that 0 that we talked about a moment ago, right? So here, we're asked to find the remainder when this polynomial is divided by x minus 1. So instead of doing like, we could do polynomial long division or we can do synthetic division. But if we just want the remainder, we can evaluate this function when x is 1, right? So if we want the remainder theorem says the remainder is going to be, in this case, is going to be f of 1, because 1 is our a. So that's going to be 2 times 1 to the 5th minus 4 times 1 cubed plus 5 times 1 squared minus 7 times 1 plus 2. That's going to be 2 minus 4 plus 5 minus 7 plus 2. Okay. 2 plus 2 is 4 minus 4, so this plus this plus this adds to 0. 5 minus 7, the remainder is -2, right? So f of 1 being -2 means that the remainder is also -2. Okay. And we can verify it, like if we do synthetic division, our 0 in this case is 1. So if we put 1 in a chair, we do 1 in the chair and do synthetic division, we got 2. The 4 is missing, so we need a placeholder. 5, 4, 3 is going to be this guy. I think we only have one placeholder. We started with the degree 5 polynomial, so we should have 6 numbers: 1, 2, 3, 4, 5, 6. Okay. So then when we do synthetic division, the first number just comes down. On the diagonal, we multiply. So 1 times 2 is 2. Vertically, we add. Then we multiply. We add. We multiply. Add. Multiply. Add. Multiply. And add. Notice we got the same thing in either case. Right? So that's the remainder theorem, right? So when a polynomial is divided by that linear binomial right here, then the remainder is equal to f of that 0, basically, f of a. So the remainder we got was -2. Okay. So then let f of x be this. We're asked to find. So this is basically the remainder theorem, but the other way. So we evaluated the function at that 0, and we got the remainder. Now we can evaluate this function when x is -3 by finding the remainder, right? So now we're just kind of working the opposite direction. So that means that -3 goes in our chair, okay? And we're going to do synthetic division. Now we got a 1, 3, -5, 8, and 75, right? We started with the degree 4. We should have 5 numbers. 1, 2, 3, 4, 5. Okay, so we didn't have any placeholders here. So then when we do synthetic division, the 1 comes down. On the diagonal, we multiply. We get this. If we add, we get this. Multiply, add, multiply. If we add, we get what? 23. We multiply, -69. And then if we add, we get 6. Okay. So what this is saying, f of -3 should be 6. Okay, let's see the time. Okay. So again, I feel like there should be questions, but it's okay. So one way is to evaluate. So like if we were to evaluate f of -3, if we plug in -3, eventually you'll get that the result is 6. Another way is to use synthetic division. The remainder is 6. So that means that f of -3 is 6. I mean, it's 6. So either method yields a value of 6. Okay. So polynomial f of x has x minus a as a factor if and only if f of a is 0, right? So that means we have a 0 remainder. There's no remainder, okay? Let me just check on you guys in Zoom. Chat looks good. I'll get the student. Okay. Let's keep going. So given that 2 is a 0, so we were given a 0 of this function, solve the polynomial equation, right? So, trying to factor something like this off the rip might be a bit daunting. So fortunately, we were given a 0. So let's go ahead. Let's confirm that 2 is indeed a 0. So if we do synthetic division with that 2, thank you. If we do synthetic division with that 2, then the remainder should be 0. Okay, so we write the coefficients. We have a 3, 2, -19, and 6. We done 3, 2, 1, 0, right? All the powers were accounted for. So we didn't need any placeholders. Okay. The 3 comes down on the diagonal, you multiply. 3 times 2 is 6. Then we get 8, 16, -3, -6, and the remainder is 0. Okay. So since we started with the degree 3. At this point, this is called a depressed equation. Now we're at a degree 2. Okay, so we get something like this. So let's write out what we have so far. So we confirm that 2 is indeed a 0. So that means that the factor is going to take on the form x minus 2. And then we still have this 3x squared plus 8x minus 3 equals 0. So we want to try to factor this guy. So if we're going to factor this, we're looking for two numbers that multiply to give us -9. You got to say A times C. Okay. Two numbers that multiply to give us -9 to add to give us 8 are going to be 9 and -1. I'm going to use the box method for factoring. Oops. To factor this all the way out. So in the upper left-hand corner goes the 3x squared. The bottom right-hand corner goes the constant term. And that 8, let's do these guys in orange. We're going to rewrite with those numbers that we found. And again, here we got 9 and -1 were the two numbers that work. Multiplied to give us -9 and added to give us 8. Here we go. Come here. Please, if you could just be quiet, you can stay. But if you got to bark, I'm gonna silence you. Okay. So the 8x we're gonna rewrite. So we can rewrite it as the 9x and the -x. Okay. So then when we go to factor, if we look at the 2 on the top, what do the 2 on the top have in common? They both have what? 3x. So we can factor out a 3x from those two guys. What do the 2 on the bottom have in common that we can factor? We can factor out a -1. What do the 2 on the left have in common? They both have x. And what do the 2 on the right have in common? They both have 3. Okay. So then what that's telling us, the x minus 2 just comes down. And the claim is that this guy factors into 3x minus 1 and times x plus 3. Right? And we can confirm, it's a good idea to just multiply out to confirm that that works. So then now that we have the original polynomial in completely factored form, we use a zero factor property. So essentially, we set each factor to 0 and solve. Long story short, you're going to get x equals 2, 1/3, and -3. And again, it's a good idea to check to make sure that these work in the original. I think just for the sake of time, I'm not going to. Yeah, sorry guys, my energy is like low. It's tough this hour because like it's like after lunch. I've been talking for like hours by the time I get to you guys, and then all of a sudden I just got like a headache. It just came out of nowhere. So I'm like, but I know basically I just need to be active. I got to get out, get my cardio going, and eat cleaner. You know. Okay. So this is what we got. I think this is good. Let's get rid of this. Okay, so you can see where they did synthetic division. They got the 0 remainder. Okay, she's actually chilling. Normally she loses her mind. She's in the hammock right now. So she's just like, well, I'm talking about my chihuahua. You know, so she's like in the hammock. And so she's like, I'm cozy. I'm good. You know, normally she's acting like a maniac, but I'm like, okay, well. Okay, I think we got all these results. So let me see the time. We're almost there. Okay, I guess we can give this one a go. So it says the combined petroleum consumption seen in quads by a group of the most economically developed countries in the world during 1996 to 2011 can be modeled by this function, right? So we're given this model. All right, we're just given this model. Where x equals 0 represents the year 1996, x equals 1 represents 97, and so on. The model indicates that after 5 years, 238 quads of petroleum were consumed in 2001. Find another year between 2001 and 2011 where the model indicates that 238 quads of petroleum were consumed. So in other words, they're asking us to set this equal to 238 and solve. And we know that when x is 5, that's one of our solutions. So we're trying to find another, right? Okay. Let's start by, I need a page. Okay. Let me get a copy of this. And I need it from like here. Come on. Okay. All right. She's almost snoring like a grown man over there. It's good, I guess. How's it doing that? Okay, that's fine. Okay. So we want to set this, let me see. So we have 0.021x cubed minus 0.973x squared plus 11.347. I think there's supposed to be an x there. I think that's a typo. Plus 202.965. That should equal 238. Okay. So if we subtract 238 from both sides, okay, a lot of this is repeated. Hey Siri, what's 202.965 minus 238?
202.965 minus 238 is negative 35.035.
Okay, so we were given it after 5 years, it equals to 238. So 5 should be a solution of this equation, right? So we could do synthetic division to confirm it. So if we put 5 in the chair, we should have 0.021, okay. Negative 0.973, 11.347, negative 35.035. If we do synthetic division, the remainder should be 0. Okay. All right, so let's do like this time. That's fine. So the first one just comes down. Oh, 0.21 is starting to slow down. On the diagonal, we multiply 0.021 times 5. We get 0.105. Okay. We're going to say that minus 0.973. We get a negative 0.868. Then we're going to say that times 5. Negative 4.34. Then we're going to say plus 11.347. 7.007, and then we're going to say that times 5, and that is promising. That's exactly what we anticipated. Because 5 was the solution, that means the remainder should have been 0, which it is. Okay. So then we started with a degree 3. So then at this point, we now at a degree 2. So this is squared, this is x, and that's plus. We could just use the quadratic formula to solve this. Quadratic formula. The negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. Right? That's how one of my students of the past remembered this formula. So I don't know. They shared it with me. I think the second time he shared it, it just stuck inside my brain. So that's how I remember it now. Okay. So then let me see, negative b, so it's going to be 0.868 plus or minus the square root of 0.868 squared minus 4. Our a is 0.021. Our c is gonna run out of space, 7.007. Square root of all of that, all over 2 times 0.021. Okay. So we get 2 results from there. So we can work here. Okay, that's fine. Okay. So then the first one we can do is, let's do parentheses, 0.868 minus the square root, 0.868 squared minus 4 times 0.021 times 7.007. Okay. That closes off the square root. That closes off the top. We're going to say divided by parentheses 2 times 0.021. Okay. And with something like this, we got an okay. One result we got was 11, right? That was where we did minus. We need to go back and do one more and change the minus to a plus. Okay. So I think the instructions said, let's see, find another year between 2001 and 2011. Okay. So if 0 represents 96, 5 represents what? 2001? Okay. So we want to find the year between 2001 and 2011. We got 11 years later and 30 years later. I think it's the 11 years. So is that 2007? All right. 2007. Because 30 is outside of that 2011. 30 goes too far out. So when X is 11, then the year is 2007. Okay. I feel like there should be questions. Oh, sorry, my head is like. I think that's enough for one day. We got 2007. Let's just confirm that that's correct. Okay. 11 or 30.3 bars. Since 11 is between 5 and 15, we use this value. So in 2007, the year corresponding to X was 11. The combined petroleum consumption was 238 quads. Okay. The rational zero test, I go into the details on this on my recorded lecture, so I'm going to have to direct you there. Are there any questions? I feel like there should be questions. Are there any questions? Okay. Let me go ahead and make a copy of this available for you guys. College Algebra 1. Look at the notes. Updated daily. This is week. Okay. So when this bar finishes loading, you'll get a copy of what you saw me working on. And if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of the day, guys. Okay, take care. Peace.